In this question, we've been given two column vectors and we've been asked to first find and sketch the resultant vector. The resultant vector is the vector that you get from combining the two vectors we've been given, from adding together A and B. So the resultant vector, A plus B. If we substitute these column vectors in, the resultant of the horizontal components is -2. The resultant of the vertical components is 16. Our resultant vector is -2, 16. We need to sketch this. Here's my start point, this thick dot. I'm going 2 to the left and then up by 16. It's just adding on the arrows, annotating the sides, and here's an angle that might be useful later. In part B, we're asked to find the magnitude for the resultant vector. The magnitude we can find using Pythagoras. The magnitude is the length of the black line. So using Pythagoras on the two blue dashed lines on the two blue components should get us the length we're looking for. The magnitude is 2 squared plus 16 squared, which is the square root of 130 or 16.125. Part C says we should find the bearing of the resultant vector. Well, a bearing is an angle measurement, but a specific angle measurement, one where we start from facing north and we turn clockwise until we get to our vector. So in this case, you can see from the diagram, I've drawn this red rotation, this red angle, which is going to be 270 degrees. That rotation won't get us all the way to our vector. If I add on alpha, well, that will be the bearing. Alpha can be found easily from the diagram. We're just going to work with the triangle. We know that tan alpha is the opposite over the adjacent. In this case, the opposite over the adjacent is 16 over 2. So alpha is inverse tan 16 over 2, which gets us 82.87. Going back to the bearing, we need to add that on to 270. And we get a bearing of 352.87 degrees. That's the bearing of the resultant vector.